So welcome back to the embedded system class. Today we are going to discuss about processor selection for an embedded system. So every embedded system has a processor. So processor is a application. First point is application related processor we need to select. So different types of processors are microprocessor, microcontroller, ASICs, VLSI related. So VLSI related are FPGA or CPLD, and next one is DSP related. So first of all we need to choose the processor depends upon application. So if we are for example if we are doing speeching DSP related or signal processing or video or audio compression related application, we need to choose DSP related processor. So for any processor selection, so mainly we need to remember 2 points. So first point is the performance of the processor, how fast our processor is, and second one is nothing but low power consumption. So mainly processor selection will depends upon these 2 points. So performance and multitasking. So performance and low power consumption. So first point for selecting any processor of an embedded system, first one is clock frequency. How fast the clock frequency, our processor also that much fast. The processor's performance is depends upon clock frequency also. So second point is computing performance speed, the speed of operation. Here we need to check about architecture. So which architecture we are using. Almost all embedded system they use RISC processors and superscalar processors, superscalar architectures. So a RISC is a reduced instruction set computer. So where we have very less number of instructions, large number of registers. So as these are very less number of instructions, the performance of the processor is very fast. So the program size is very large code size, but very less number of instructions. So it supports load and store architecture. So the performance is very fast, and it is a superscalar architectures. And the processor have to be a superscalar architecture. So superscalar means which will allows multiple tasks at a time. So second point is computing performance. The speed of the operation depends upon either it supports pipelining or not, or it is a superscalar architecture. And B point is pre-fetch cache unit. So whatever the instruction we are fetching, so pre-fetch means we need to store what is the next instruction to be fetching, so that instructions address is stored in PC program counter, and it is a RISC architecture as I am explained now. So third point is register windows. Register windows is also a concept which is in multitasking. So using register windows we can perform multiple tasks. And fourth point is nothing but low power operation. So this is a auto shutdown feature. Auto shutdown feature. So whenever a embedded system, example smartphones or a general purpose computer, if we are not use a long period, it will automatically shut down, so that the power consumption will be less. So auto shutdown feature is very important for any embedded system. Automatically shut down. So it has to clear the cache, and it has to shut down the system also. So next one, fifth one is burst mode access. So burst mode access is about data processing. So how fast we read the instruction, how fast we write the instructions. So burst is fast about read and write operations. Sixth one is atomic operation unit. It is also a multiple task unit. So using atomic operation unit, we can perform multiple tasks at a time. So next one, seventh one is big endian and little endian. So this is nothing but how we are going to store the registers in memory. If we store the registers value in memory from least LSB to MSB, then that is called as little endian. If we store the value from MSB to LSB, so then it is called as big endian architecture. So the processor selection of an embedded system, these are the different points. So we need to select the processor, depends upon clock, depends upon speed of the operation. So whether it is it allows multiple tasks at a time or not. So auto shutdown mode feature is there or not. Burst mode, how fast we are writing and reading the operations. Atomic unit, how we store the data in memory, whether it may be big endian style or little endian style. So this is second topic in third unit, processor selection for an embedded system. Thank you so much.